Hello. In this short video, we're going to show you some clips from our amazing security training courses. We've a clip from a beginner level course, one of our advanced courses, and one of our specialist security training courses. But first, who are we? At NotSoSecure, we hack, we teach, and we protect. We're a global organisation with presence in the US, UK, India, and consultants worldwide. We deliver penetration testing to some of the largest brands worldwide, from financial organisations, software companies, retailers, government groups, and many more. Our training, as we'll cover in this video, includes both offensive and defensive security courses from beginner to advanced levels. We also offer consultancy in the area of DevSecOps, helping organisations build security into their software development lifecycle, and, as part of the wider Clarinet cybersecurity group, we have a range of managed security services and audit capability. We're one of the largest training partners at Black Hat and present at their events worldwide. You'll also see us at other leading conferences worldwide. Our courses are available via training partners and directly from ourselves for both individuals and private corporate bookings. All of our training is live instructor-led training with advanced hands-on labs, all available via remote delivery. Finally, and the thing that really sets us apart, is that our trainers are hackers and our hackers teach. They bring real-life experience of the latest hacks into the classroom and knowledge from the latest research into our security testing. And we have a strong track record of research and development to ensure we're keeping on top of the latest trends. Make sure you check out our blog at NotSoSecure.com. Now onto our training. Our ethical hacking training can take you from beginner right through to advanced levels and is suitable for those wanting to move into penetration testing, as well as for a wide range of security and IT professionals who want to understand modern cyber attack techniques. This is supplemented with a range of specialist courses, including hacking and securing cloud infrastructure, as well as application security for developers and our popular DevSecOps training. And now for a sample of our training, starting with a beginner level course. We're going to start with an excerpt from our basic infrastructure hacking course. This course teaches a range of tools and techniques to get you started in this field. In the section we're going to look at, Pratik is giving an example of the latter section of the course. After he's shown how to gain access, what post-exploitation tasks can be achieved. This section is about 6.5 minutes long. Take a look or skip through for an example of one of our advanced hacking courses.
The post-exploitation part on Windows. Once you have a higher privilege, what are the next things which you would be looking at? Whenever we talk about Windows post-exploitation, after gaining a system level privilege on the box, you can look for cached domain credentials, you can look for clear text password for users who are logged in locally or remotely. There are multiple tools which are capable of extracting these credentials from the Windows machine. So if you talk about Metasploit, we have multiple modules which can be loaded into Meterpreter to extract these credentials. Then there is one of the powerful tool called Mimikatz, which also has a capability to extract the credentials from the Windows box. Now, when we talk about credentials, what are the interesting credentials which are there in Windows? So Windows has Security Account Manager, which we call it as SAM. Then we have cache domain credentials. Then we have local security authority and LSAS process memory. If we talk about SAM, this is nothing but a file which holds the NTLM hash of all the local user. By default, this particular file is located at system32/config/SAM, and it is encrypted with a sys key, which is present in the security file, which is also located at the same location. So as an attacker, if you have highest privilege on that box, then you can use tools like SAMR dump, you can use tools like FG dump, or you can use Meterpreter shell to get credentials from SAM. Then cache domain credentials. Cache domain credentials are basically credentials which allows user to authenticate to the machine whenever the domain controller is not available. So at the simplest level, your machine basically stores your domain credentials in the machine cache. So there are multiple group policies which are available, or as a network admin, you can configure on that particular network, which would allow you to play with the number of how many cache domain credentials can be stored at every user laptop. Then we have local security authority, which is called as LSA. Local security authority is a protected system process that authenticates and logs users on the local computer. Then there is a very interesting process, very popular process called LSAS process memory. It is also a protected process. This particular process memory allows you to gain plain text credentials of the user, depending on which system you are trying to exploit. So in this next video, I'm going to show you the post exploitation technique, and we are going to harvest the credentials from the Windows machine. I'm going to use the same session which we've just received from our last exploitation part. As you can see, we are running with the system privilege. Once I run the hash dump command, this is where your interpreter basically gets SAM file and the system file. It would take a system key from the system file, and then it would decrypt the SAM file. And this is how your NTLM hashes would look. So you have admin user, this is the part of your NTLM hash. This is nothing but an RID and so on. Then we can use post exploitation module, which could allow us to get the LSS secrets from that particular machine. Again, I'm going to set the session as 2, and we are going to get the LSS secret. So if you can look at this particular location, you will see that now we have got credentials of service user, which is a local user, and this is the password value. One of the key thing to note here is your LS secret also retrieves the value of $KM, which has some significance when we try to crack the cache domain credentials. The next part is basically gaining access to the cache domain credentials. Metasploit again has a cache dump post exploit, which would allow us to get the hash of cache domain credentials. Key thing to note here is it basically fetched that $KM value. It would try to decrypt that cache dump, and it would give us ms cache to hash of this particular user. Now, as an attacker, we have to crack these hashes. Like you can use hashcat, which has a capability to crack ms cache to kind of hashes. Then we are going to load modules. This is how you can load mimikatz in the interpreter shell. And once you load the mimikatz, you can use inbuilt commands like wdigest or create_all, which would allow you to dump the plain text credentials from the LSAS memory. If you remember, when I was talking about the credentials which can be extracted from LSAS memory, it varies from your operating system. So if you have an operating system which is running on Windows 7, you can get the plain text credentials. If you're using Windows 10, then these credentials would be an NTLM hash of that particular user. Now, you may have already been aware that Windows 7 has come to an end. So Microsoft has declared that there are no security patches for Windows 7 from January 2020. It is decided to be an end of life for Windows 7.
And now for an example from one of our advanced courses. For the video we're going to look at, we're going to take a look at a section of our Advanced Web Hacking, our Black Belt course. This course covers a range of advanced techniques focusing on the manual testing techniques and vulnerabilities that automated scanners typically aren't able to test. In the example we're going to look at, Dhruv is demonstrating a section of the course which looks at remote code execution using insecure deserialization. This clip is just under 9 minutes. Take a look or skip through to see a walkthrough of part of our Hacking and Securing Cloud course.
Now, another attack that we have in our course is insecure deserialization. And if you know, nowadays deserialization have been widely recognized and it has even made its way into the OWASP top 10 as well, right? We are going to be talking about .NET deserialization, but before doing that, let's understand what serialization is, right? So serialization is nothing but conversion of data from one form into another. Now, this is a very textbook definition, right? If I just say that it is used for storage and transmission of data across the network, and saying that an object is converted into a stream of bytes, which is either stored in a file or in a memory, or stored in the database, or sent over the network, and on the other end, the stream of bytes is again converted back into objects. This is the whole process of serialization and deserialization. It is difficult to understand the concept with some theoretics, but the best way is to give an example. So let's say you're playing an online game between two players. Maybe let's say you're playing FIFA, right? So what would happen is one user ends up selecting a particular player, and he moves that player a few steps forward and few steps to the left. So these three objects, the first object selection of a player, the second object moving him few steps forward, and the third object few steps to the left, are converted into a stream of bytes and are sent over the network to the other end, or to the other competitor that you're playing with. And on his system, when this thing deserializes, it first deserializes the first stream of byte, that is selection of the user, selection of the player, then moving that player few steps forward, and then moving that player few steps to the left. So this is the whole flow how serialization and deserialization happens. And if you see, it is very fast, right? Now, this concept is basically used to optimize the delivery of the content from one end to the other in a very convenient mechanism. Now, almost all the languages that you know of support serialization. You have like different languages ranging from Java, PHP, .NET, COM, Ruby, Python, and all other OOP languages. They all support serialization and deserialization. And almost all of them have had bugs and deserialization routines which lead to remote code execution. And in our course, we also have made sure that we have labs around most of the serialization concepts. So we have labs for Java serialization, three different types of Java serialization. So you have binary, you have XML, you have JSON, then you have PHP object injection, .NET serialization using three different concepts, followed by Python serialization, etc. And if you see, there are a lot of CVEs that are found for these serialization vulnerabilities as well. So what is it with .NET serialization? How do we understand .NET serialized data, and how do we try to exploit it, right? So let's not waste time. Let's jump into it. So the .NET framework has multiple types of serialization. It has binary serialization, which is also called as runtime serialization, followed by XML and SOAP serialization and data contract serialization. What we are going to talk about in this webinar is binary serialization. So what exactly is binary serialization? Now, binary serialization in .NET framework, there is a class called as binary formatter that supports this serialization mechanism, and it is fast and lightweight. Now, what this does is that this class serializes and deserializes an object or the entire graph of connected objects in the binary format, or you can also create gadget chains, because it it serializes the entire graph of connected objects, right? And which is the particular class that is used? The class that is used is system.runtime.serialization.binary formatter, and it is made available since framework 1.0 of .NET. So here's a quick example. If you see, we've highlighted two pieces of code within our sample example. First one is binary formatter dot deserialize and a particular value that is passed to it, and the other box is binary formatter dot serialize and a value passed to it. So this is nothing but a simple deserialization and serialization example. If you look at the output on the right, the serialized data reads as double A EA double A D slash, and deserializing this particular data leads to the actual value that this is a sample data. Now, to understand that there is a .NET binary serialization happening in a .NET framework, the signature to identify is with this particular initial keywords, that is double A, EA, double A, D slash. If you ever see that in an application, then it has to be 100% a binary serialized data. And you can go ahead and play with binary deserialization vulnerabilities, right? So how do we test for the serialization vulnerability in .NET? If you all know that there is a very famous utility for Java serialization vulnerabilities called as bisoserial.jar. However, for .NET also, there is another utility called as bisoserial.net. And this is for all the payloads that can be used to generate for Windows system. And there are various gadget chains available within this particular utility. These utilities are basically a set of collection of different vulnerabilities found by different people over the internet and shared on a collab network. So let's go ahead and see the example. So if you see here, I go back to the admin webhacklab.com and I'll capture the request. Now, if you see, there is a cookie called as NSS temp, and if you see the initial value, it reads as AAEAAAD, which is, as I said, the signature to identify that this is a binary formatter of .NET. So we'll simply just copy this and we'll try to see what happens. All right. So let's send this to repeater. And now I will go to that utility again. So I'll go to utility.webhacklab.com and I will go to visoserial.net. So I'll click on generate the payload and I'll simply say that it is a binary formatter and I'm using a gadget called as type confused delegate. Explaining gadgets in a webinar would be very difficult, but long story short, gadgets is basically a set of chain that allows you to inherit multiple classes till you reach a class which allows you to do remote code execution, right? So I'll simply give a PowerShell command. So I'll say that I want to execute PowerShell.exe and I want to invoke a web request. Why do I want to invoke a web request? I'll simply send a request from that vulnerable server to my machine by asking him to send me the environment variable username, right? So in PowerShell, there are environment variables. So if you see here, I'm giving /$env username. This environment variable username is nothing but the user running that particular web server. So I'll simply click on generate and I'll copy this payload that is generated. Excuse me. And I'll send it across. So I'll simply start a Python server because I'm going to expect a connection back to my particular IP address where I've requested the PowerShell, and I paste the payload, right? And I send this value. And if you see here, there is win2k12iis. So basically, this is the user that is running the web server, and I was able to execute PowerShell. But obviously, this is not where we should stop. We obviously love to take shells, right? So here's a PowerShell script which we have written, which gives us a reverse shell. And here we basically connect back to our IP on port 4444, right? So I'll simply just go ahead, generate the payload. I'll copy this payload again, and I'll also start a list now, right? So I'll just go ahead, start a list now. So netcat on port 4444. And once it is hosted, I will simply go ahead, put my payload and push it, right? So let's configure and send, right? So if everything goes correct, there we go. We have a shell, right? And I can simply run any command that I want and I can try to elevate my privileges and move on from here, right? So this is how you can attack .NET binary serialized data.
Our final clip is of one of our specialist security courses. Here, Anthony is giving an overview of part of our hacking and securing cloud infrastructure course.
Now, one of the number one targets for us when we find out a set of services we're attacking are hosted in the cloud is what we call the metadata API layer. Effectively, it's a layer provided by all of the cloud providers. They've all agreed on a very similar format for this as well, which basically shares system environment information. So you might recall this is what we were accessing through SSRF in the case studies, a couple of the case studies from right at the start. So generally speaking, you just make HTTP requests to a non-routable IP address, which is 169.254.169.254. I don't know how they all came to agree on that, but it's usually non-routable for network cards that don't get configured to a network correctly. Some of the providers require extra headers, so this prevents potentially reflected attacks because you can't reflect a header as part of an SSRF type attack. So by requiring that header, Azure certainly are very well protected from this. AWS and GCP, yes and no. I haven't really got time to explain that in great detail, but sometimes yes, sometimes no. AWS has an additional thing where they don't actually allow access to the metadata API from functions as a service. So Lambda functions can't access the metadata API. However, there are ways around that as well, because that information does still need to be exposed to the function. It's actually done in environment variables. So if we gain access, we can retrieve temporary creds, their service account credentials. So it's effectively a full set of security credentials to allow us to configure our command line tools to access the entire AWS APIs. They're temporary, but they last for minutes to hours. And so generally, if we find that we've got access to that, that's going to be our #1 target for gaining access and then hopefully pivoting between services. Now, SSRF, I've mentioned it a few times now, so I should probably explain what it is. Basically, it's a vulnerability that allows an attacker to trick the application into sending requests for them and reflecting the results back. The situation where this is useful is if we have compromised a host that can see things that we can't. So whether that's a host that's on the edge of a network and it can see inside the network, we can't get inside the network, but we can ask it to send requests to internal systems and to return the results back to us, which means we can use it for all sorts of things, potentially accessing web pages, internal applications, but also weird stuff like performing port scans and acting as a proxy. Now, a really good example of a HTTP request that we wouldn't be able to send externally, but that we can from internally, is access to that metadata API, which means if we're able to have reflected requests sent onto that API and the results returned to us, that is a really good way of gaining access to those service tokens that we were talking about, as temporary service account tokens. So I'm going to do a couple of demos. This is a longer one here. The first one here is going to be our web app 1.victim.cloud that we discovered right at the start in the enumeration phase. And you can see that what it effectively is a proxy. It's a bypass application that was produced at some point. It's now unsupported, but it's still running, which hackers find very, very exciting when they find things are no longer supported, but still present. And what we've done is we've just gone to a NotSoSecure website, but what's actually happening is we're still at web app 1.victim.cloud. We've got a parameter URL equals, and URL equals notsosecure.com, and then it goes to the site, it accesses it, and it shows us what it sees. Sounds useful. Let's ask it what my IP address is. And it's found an IP address. So what this does, it goes off to a service called what'smyip.org, and the service responds, this is your IP address. So effectively, this is the IP address of the device that accessed what'smyip.org. Now, if I do the same thing locally, I have an entirely different IP address. So I can say with some confidence that I didn't send that first request. It came from the host that I was compromising. Now, if I look up that IP address, I can see that it's owned by Google. So I am probably compromising a host that's operating under Google Cloud. Now, if I send that to metadata.google.internal, which is effectively Google's name server for 169.254.169.254, let's rewind that a little bit, I get some responses which are endpoints that I can explore within that metadata service. So I'll do the same thing using curl requests locally. So I'm doing the exact same request here, and I've received, in the first case, compute metadata in 0.1. So I'm going to add compute metadata to the end of my request, and I now have v1 and v1 beta 1. Now v1 requires the headers that I was talking about. It requires metadata version Google or something like that. So I'm not going to get a response, and you can see here I've had no response if I do it in a browser either. But if I change that to v1 beta 1, the header requirement is not present. Now this was supposed to be deprecated in December, but it hasn't been. So I'm now going through the service through the endpoints. I found one called service accounts. I'm going to look inside a service account called Terraform Robot Storage, and I found one called token. And if I look inside that, that is a temporary service token, and that's how easy that was to retrieve. Now, if I do a very similar thing, just show you in the browser as well. Here's another one. This one's hosted in GCP functions. So instead of being a web app hosted within GCP, this one's hosted in functions. We do the exact same thing. There's another IP address that's not mine. And by asking it to proxy 169.254, I found compute metadata, and I'll follow the exact same steps, go through v1 beta 1. Just stick that at the end, and I'm just going to fast forward to the end, and again we pulled out an access token just as easily. So we can do that both from a web app and from functions.
We hope these short samples have shown how these practical, instructor-led courses can accelerate your information security skills. Please contact us to find out more, and we look forward to seeing you in one of our classes soon.